Hello and welcome to Algebra 1, Chapter 1.5, and today we're going to discuss the distributive property. So that you know our goals, we're going to use the distributive property to evaluate expressions, and we're also going to use it to simplify expressions. So we have several uses for the distributive property. So if you don't remember the distributive property, it is if you have a number immediately outside of a sum or a difference, okay? Not a quotient or a product. It has to be outside of a sum or difference. You distribute it through, meaning we multiply it to everything inside, right? And it doesn't matter if the number is in the front or in the back, you still distribute it the same either way. So down here we have kind of the four options into a sum from the front, a difference from the front, sum from the back, difference from the back. You really get the same thing. And as far as the difference between sum and difference, I would just say you need to watch your signs. So Julia walks 5 days a week. She walks at a fast rate for 7 minutes and cools down for 2 minutes. Rewrite, I'm going to write it here, 5 times 7 plus 2 using the distributive property and evaluate the total number of minutes. So to begin with, we're going to do this intermediate step of when we rewrite it, and we know we're going to distribute, we're going to say 5 times 7 plus 5 times 2. So I want you to do that step, even if you know what that's going to equal. Do that step for me. And then make it 35 plus 10. So now we're evaluating it, and that is 45. Oh, so sorry. 45, and then that would be minutes that she walked. Okay, so one more time, when it says to rewrite it using the distributive property, I want you to do that intermediate step before you multiply. So in this case, we're going to write 9 times 5 plus 9 times 1, and if you switch the order, I don't think that matters. Then go to evaluate. We have 45 plus 9, which is 54. So this step right here is the rewriting using the distributive property. So we have 3 times 11 minus 3 times 8. So we're looking at 33 minus 24, which is 9. Okay. So no, you're not going to have to do that forever, but at the moment we're talking about the distributive property. I want that rewriting step in there. So one real life use for distributive property is it helps us to make mental calculations, something that we might not know. For instance, if I said what's 5 times 62. Well, off the top of your head, you might not know 5 times 62, but maybe if we break 62 down into 60 plus 2, maybe you know 5 times 60, and you know 5 times 2. So you can just mentally do this in your head. 5 times 6 is 30, so we add the 0, we get 300 plus 10. So we're looking at 310. So there is a great use of the distributive property just on an everyday basis. So that's what we're looking at here. If I'm trying to multiply 12 times 82, and I don't know what 12 times 82 is, some of you might, but could I rewrite it somehow? So the idea is that we split it up and we make it 80 plus 2. Now, you need to know what 12 times 8 is. So 12 times 8 is 96, and we'll add a 0. So that's going to be 960. And 12 times 2, we're looking at 24. So 984. So rewrite it. So this is an answer here. That is rewriting it, and then we evaluated it. So make sure we have both answers. Okay, so next we're going to use our distributive property, rewrite them, and then simplify. Okay, so we're still rewriting. So this is going to be 12 times y plus 3, and I switched the order there, that's okay, 3 times 12, so it's 12 times y is 12y. 3 times 12 is 36. Can I simplify that? Not any further than that. So there's our answer. Okay, so rewriting the other one, 4 times y squared plus 4 times 8y plus 4 times 2. And then simplify those. We're going to get 4y squared. 4 times 8 is 32y. And 4 times 2 is 8. So neither of those have like terms. We're going to talk about like terms next. So first of all, what is a term? We have several definitions of a term. A term can be a number. So 3 is a term. It can be a variable, like y. Or it can be the product or quotient of numbers and variables, like 3y, because that's 3 times y. So that's a term. A term has no addition or subtraction in it. So like terms are terms with the same variables, including exponents. So 3x squared and 5x squared are like terms because they have the same variables with exponents. Okay, and remember you can only combine like terms, meaning you can only add and subtract like terms together. And the coefficient is the numerical part of the term. Okay, so let's look at these two examples. How many terms do I have here? I have 3 terms. Okay, so there's my 3 terms. Are any of them like terms? All right. No like terms. And what are their coefficients? Okay, so 14, 13, and 27 are your coefficients. Okay, how many terms do I have here? We have 3 terms to start out with, but are any of them like terms? So we actually can combine these like terms here. I'm going to keep negative 2x squared y in front plus 13xy. So now how many terms do we have? We have 2 terms. There's my 2 terms. There's a plus sign there in the middle. Are they like terms? They're not, because we combine the like terms, and their coefficients, negative 2 and positive 13. We've got a few more definitions to look at. Equivalent expressions are expressions that denote the same number. So for instance, 1 plus 2 is equivalent to 5 minus 2. They both denote 3. So those are equivalent expressions. And simplest form is an expression with no like terms or parentheses. So you've combined everything and you've gotten rid of parentheses by distributing. So we want to simplify these. 17a plus 21a, are they like terms? They are, so we can combine them. So 17 plus 21, 38a. Okay. And 12b squared minus 8b squared plus 6b. Are there any like terms there? There are, right? They don't all have to be like terms. You just are going to combine whatever like terms you have. So 12 minus 8 is 4b squared plus 6b. No more like terms, no parentheses. All right, that's what I have for you today. We'll finish the rest in class. Let me know if you have any questions, and have a great day.